Right, so this is the second lesson on volume. In this lesson, students will actually use these two formulas to find the volume of rectangular prisms. This first formula is just as important as the second one, so make sure that we're hitting on both. Here, the large B, the capital B, represents the area of the base. That goes back to what we were talking about yesterday. You find the area of the base, and then it's however many layers we have is the height. So we're going to start today with a model very similar to what we started with yesterday because that's what students were familiar with. My length is 3 here. Notice that I'm labeling length is 3 and my length is 5 and my width is 3. I know that I have 15 on the first layer and I have a height of 2. So that means I have 15 and 15. Two groups of 15 is 30. We can also show this using this formula. Here I can show that my volume is the length times the width times the height. So if I multiplied 5 times 3, that's how many cubes I had on this bottom layer, and then I have 2 layers in all. So 5 times 3 is 15, I have 15, 2 groups of 15 is 30. The other way that we could show this is using this other formula. Volume is big B times H, where big B is the area of the base. And here again, I know that 5 times 3 is 15, so 15 times 2 is 30. Now we move into not having those little unit cubes to show us how many are on each side. First, I'm going to start by labeling length, width, and height. And then I'm going to write my formula, and I'm going to substitute values in for my length, my width, my height. I'm going to do my scratch work over here. And then this second question, if you turn the prism on its side, do the perceived dimensions change? And so let's actually have kids turn their paper so that it's sideways, and then they can see that the new length is 5 and the new height is 12, okay? Does the volume change? Why or why not? And what we want students to recognize is if you multiplied 5 times 16 times 12, you end up getting the same thing as 12 times 16 times 5 because of the commutative property. And so it really doesn't matter which you label, length, width, and height, but all that matters is that we're thinking about this as area of the base or area of one dimension or a two-dimensional figure, and then however many height I have, however many layers it is for the height. And then this is the first time that they've seen where we're actually solving for one of the missing sides. So we're given the volume, so we're going to write our volume formula, and then I need to solve for the length. So I'm just going to substitute a question mark in there. Don't worry about using variables. Students are not responsible for using variables in 5th grade. And then I have 6 times 5 is 30. 240 is equal to some number times 30. Well, what is that number? I can use my multiplication facts to figure out that that's 8. If I needed to, I could also divide 240 by 30 to get 8 because I know that there's a relationship between multiplication and division. Kids did very similar work in 4th grade with finding area. So if they said the area was 24 feet squared and I gave you the length and you need to find the width, they did the same work with a question mark.